All right, so let's get back to presentations. So I'm really happy the next two presentations to have been able to convince my co-authors and friends Matteo Maggiori and Stefano Giglio to come and present and talk about various aspects of an agenda that the three of us have been working on, I guess the better part of the last decade. I think it's really fair to say at this stage, really trying to think about how you want to go about valuing very long run investments. And we talked before about why these investments in climate change might fit into that category, how you can use data from public markets to guide sort of the choices of those discount rates, how that depends on sort of the risk properties of climate change, etc. So I'm really happy. Matteo is going to go first, talk about the first paper, and then Stefano is going to present the second paper in that sequence. So thanks very much, guys, for spending the time. Matteo, the floor is yours. Thank you.
Of course, thank you for having us here, and hello, everyone. So I'm going to present the first paper. It's titled Very Long Run Discount Rates, and the better people on the paper are my co-authors who are present, Stefano Giglio and Johannes Strobel, and I'll try to embarrass them a little bit during the talk, telling you how we got to this project. The idea is pretty simple. There's been a long interest in economics about discounting events or payments that occur very, very far into the future. This feeds into a lot of questions. Today we're talking about climate change, and that's a very obvious application today. By the way, it wasn't an obvious application in the 1970s when Nordhaus started working on this. So that always tells you that the best people go long before it becomes obvious to the rest of us that this is a big question. But climate change is a typical application because the trade-off is immediate costs and benefits, if we get these policies right, that might occur extremely far into the future, 100, 200 years from now. If you shorten the horizon a little bit, you have retirement and saving decisions or infrastructure projects for the government. These are all things that have immediate decisions and in some cases immediate costs, but benefits that occur very far into the future. And economists have long thought about how do we appropriately discount this. Unfortunately, there is typically very little direct empirical evidence. Why? Because things that we trade tend to be a bundle of cash flows, like stocks. They pay dividends for the uncertain future length to which the firms will be alive. Perhaps the best way to understand how little evidence is the recommendation that official government agencies give on how to discount intergenerational projects, such as infrastructure or climate change. They say, look, show me what happens anywhere between 1% and 7% discount rates. Now, if you ever played around with a simple discounting model, you understand that almost all projects tend to be not viable if discounted at 7%, and almost all projects tend to be viable if discounted at 1%, particularly 100 years out. The exponential function, if you do simple discounting, becomes really steep. And so minor differences in discount rates generate wildly different present values. So that doesn't really offer very much. The empirical challenge, as I mentioned, is always that we only observe either infinite maturity like equities, or we do observe finite maturity assets like bonds or dividend strips for equities, but they tend to be really short run. They tend to be 5, 10 years until they're liquid. In some cases, you might get to a 30-year bond, but beyond that, there is extremely little. So the approach here was to exploit a bit of a quirk of the way the UK and former colonies work in the housing market. I will describe it briefly. The way to think about this is that if you live in the UK and you're trying to buy an apartment, you might be offered various different contracts. One is called the freehold. That's permanent ownership. That's pretty much what most of us, whether European or from the US, are used to think of as buying a property. You pay today and you own the house and land forever and ever. Much more commonly in the UK, you might be offered a contract called a leasehold. What is a leasehold? It's a temporary ownership. It will say you will own the property for 100 years, 200 years, maybe 300 years. And one thing that is very important about this context is they're extremely common, they're quite standardized, and there's a very liquid secondary market. So what happens is I buy the house, for example, on a 100-year lease, I live on it for 10 years. 10 years later, what I do is I sell the house, leasehold, the residual length, so a 90-year lease to somebody else. And so you see the same lease trading over and over again. And there are very few contractual restrictions on leaseholders that also don't apply to freeholders. So to fix ideas on why this helps, let's just think about a simple real line, like time horizon of the maturity of the contract. The freehold is clearly the infinite line. It's the positive line that goes from 0 to infinity. A leasehold contract specifies a cap T, the time at which the contract will go back to the underlying freeholder, to the person who owns a complement to this. And if you remember your very simple Gordon discount formula, what do you have? You have D is the current rent or the current cash flow. R is the current interest rate, so the discount rate. G is the growth rate, the rate at which rents grow. And so the typical formula that you're all familiar with is that the way you value an infinite cash flow that grows at rate G and is discounted at rate R leads to the price being D over R minus G. Now, it's just only a tiny bit more algebra to figure out that if instead of being infinite, this was the claim for T years, it will stop at time T, and there will be an adjustment here that you can see in this part. There will be an adjustment that has to do with the remaining length, the remaining cash flows occurring after year T and not accruing to you, okay? Now, the nice thing is if you take the ratio between the two, if you take the ratio of the price of the leasehold to the price of the freehold, you get to a difference that tells you about R minus G. The only thing left, if these two contracts are identical, is R minus G. And if you have some information on G, then you're really learning about R. So that's what we're going for. Now, the nice thing is, because these leases are very far into the future, you might be able to learn how people think about the difference between owning the house for 100 years versus 200 years. Now, since this is a PhD class, I want to tell you a little bit how we came into this project and how, sometimes research projects, you stumble on them. So what had happened is I had lived in London and I had owned a house on a lease and I had sort of traded it over time. And I was aware of this contest, but I didn't know what to do with this. I thought it was interesting, but that was it. And then Stefano was on the job market. It was a start on the market. I was still a PhD student. He came for a Berkeley seminar. And we went for dinner and drinks. And I told him about this. And he was, I thought, like, this guy's a jolly fellow. He's very smart. Hopefully has something to contribute. And he said, oh, yeah, that's interesting. Then, of course, I was desperate to write a job market paper. He was starting at Chicago. We didn't do anything at all. And then the following year, I met Johannes. Johannes and I were on the market the same year. And we started going to dinners when we were visiting schools after the flyouts. And we got to know each other. And Johannes was also working on real estate. And I told him, oh, there's this other guy, Stefano, that you probably also met. And there is this typical thing. And, Stefano and I hadn't really gone anywhere. And if you know Johannes, you know that he's very excitable. And Johannes got excited about this. And, 2 seconds later, there were like emails and things happening. And, we were getting data and we were sort of doing a project. And so, what is the generalizable of this story? I think it's only the fact that you want to speak to people. Just, find people that you think are super smart. They're interesting. You're going to learn from them. They're going to be fun to work with. And sometimes just be very open-minded. I never thought I was going to write a paper on real estate. It doesn't really matter here that it's real estate. It's just an interesting setup to answer a more general question. And I think that one it's a much more permanent feature than the way we stumbled on it. So I thought I would mention it. Now, getting back to this paper, to fix ideas, suppose that you use 7% or 6.5% discount rate, and you think the growth rate of rents is just shy of 1%. And you're thinking of valuing a contract that has 100 years left versus the freehold, and you're asking how much value is left after that. The other way to think about this much more intuitively is how much less are you willing to pay to buy the house only for 100 years rather than forever, if those are the discount rates and the rents? And the answer is almost nothing. There's just very, very little difference. This is just a reminder that when you have high discount rates, 6.5% is pretty high, then payments that occur very, very far into the future have almost no present value. The discounting function gets very steep. And so keep that one in mind as we look at the data, because a lot of economists, when we first ask our colleagues, what do you think will happen when we look at this? I think there was a vast sense of, 70, 80 years out, you're willing to pay the same amount for the house as if you had it forever. Maybe there'll be a tiny difference, but that's because economists are trained to think about exponential discounting, and they're thinking about relatively high interest rates. Now, what we did is we said, okay, let's get the data. So again, this is a bit of a story of how you do papers. We got lucky at the time that the authority that collects all the data on housing transactions in the UK had, for the first time, digitized all the data and was willing to make it available. And so, Johannes is just incredibly skilled at getting people to give him data. And he got on the phone with his British accent, and Stefan and I were largely silent and in awe. And a little bit later, we had the universe of all housing transactions in the UK. And the particular thing that we had to convince them to give us was, for each transaction, if it was a freehold and a leasehold, and the length of the leasehold that was left at the time of the transaction, so that we could observe the time t. And this is pretty incredible data. And anybody can approach the authority to get the data. It's commercial, you have to pay for it, but if you go on our website, you will find the indication of how to get in contact with them. We then started looking at the term structure of leasehold discount. So how much less is a leasehold worth depending on how much time it has left on its lease compared to the freehold. And we also had to compute average return to housing and rent growth. Why? Because we wanted to get R to R minus G. So G here is the rent growth, which we computed to be about 0.5%. Real rent growth is not very high. And housing, it's a pretty remarkable high return asset. It's somewhere between 6 or 8% if you take very long periods of time. And so we're going to learn about this. So let's look at this together. The first thing you do is you open the data and you plot it to figure out, do we have enough variation? Our lease is trading at all sorts of maturities. If we want to compare different maturities, we need to have enough variation. So in the data, there were about 1.3 million transactions for flats, 8% of which were freeholds. And here I'm plotting the remaining maturity at the time of transaction on the leaseholds. So you can see that there's whole sorts of variation. There's a lot of variation between 0 and 100 years. There is some variation here at 150, some at 250, and then there's a lot of variation for 1,000-year leaseholds. And so there's a bit of everything. There's clearly some bunching. What happens is that when people start a new lease, so for example, I build a new apartment, I generally use a round number. I say I sell a lease for 100 years or for 200 years or for 250, and that's where the bunching is coming. The smoothness of the distribution is the secondary market. Even if I start at a round number, when it trades again at a random time when people want to sell it, it will have a different maturity. The other thing that was important to us was geographic dispersion. Why? Because the problem here is you only observe a house trading on either a lease or a freehold. You never observe the same house trading at the same time on two different contracts. So ultimately, we had to compare different apartments, for example. And here you always worry about, when you're running these kind of IDonic regressions, is there anything else that is price relevant and correlates with maturity that could screw up our analysis? One such thing would be geography. So one of the things that we wanted to know is, are these leases showing up all over the place? And here's a map of the UK. I remember Stefano did this one at the time. It looked like a major technological innovation. Now everybody can do them in 2 seconds. But at the time, it took some effort. It was a combination of us being low skilled and the time. But it looks pretty dispersed. And particularly, we had another one in the paper. When you look at central London, it's all over the place. Within the same street, sometimes even within the same building, you're going to find all sorts of different leases. And so that made us comfortable that this was a bit all over the place. Now, ultimately, what did we do? We done IDonic regressions where we have on the left-hand side the log of the price of a house, where we have the time at which transact, the property or where it is, and the time and the geography. So these phi's here, these are 3-digit postcode fixed effects. So we're only trying to compare houses that are quite close to each other. You don't want to compare, a house in the center of London in Mayfair to a house in the periphery because they might be very different in all sorts of unobservable dimensions. So we're only looking at within a postcode and a relatively tight one. And of course, we don't want to look at houses over time and compare them when they sold in different periods, because there might be prices that changed a lot over time, or the discounts might have changed. And so here we're filtering that all out, anything that is macro and common, by using month fixed effect. So what we're really asking is, When two houses or two apartments transact within the same month, within the same postcode, controlling for things we know about the house: age, the number of bedrooms and bathrooms, property size, property style, does he have a garage, does he have heating, controlling for all that. The coefficient of interest is this beta, is how does the price move relative to a freehold, considering the remaining maturity on the house. So you can think of the indicator there as being buckets for how much time is left on the lease, where the omitted bucket is you have the freehold. So we're going to compare everything through the freehold. Okay, so beta is going to measure the discount. It's going to say how much less in percentage or in log points you're willing to pay for a house that has that maturity bucket compared to a freehold. And let me show you what this looks like. So the buckets are here. This is like all houses that have 80 to 99 years left. These are all houses or flats that have 100 to 124 years left, 150 to 300, anything above 700. Now, let me start from this data point here. This is probably the easiest one to understand, is at some point, people are indifferent. If I have, whether I have more than 700 years on the house left or forever and ever, I'm going to be willing to pay the same. And you know, any amount of positive discounting where R minus G is positive will lead to that kind of behavior in the absence of bubbles and a few other technical things. Okay, but that should be the intuitive one. Now, I will argue though that for the identification is going to be a useful one. But where do we learn from is, let's consider this bucket. These are houses that have between 100 and 124 years left. And the data says people are willing on average to pay somewhere like 11% less for having a house with that maturity compared to a house that you own forever. Okay, and I keep saying house, but I really mean property, and in particular, I really mean flats. But allow me the looseness just because it's much more concrete. So that's a pretty sizable discount. If you remember the mental math that we did before, if rents were growing at just shy of 1% and we were discounting at 6.5%, this should have been almost zero. So something quite different happens. To me, to be honest, the most striking thing of this paper is actually the simplest, is that people do pay attention to this. They do discount. You know, I like very basic things in economics, and you could have taken a very different view saying people just can't think of this. They're just going to treat all this stuff the same because they can't really think about it. So even just the fact that the discounts have this shape that decreases over time, it's a result. It tells us that our basic intuition about discounting, it's kind of right. People do differentiate between 100 and 200 years. And then, of course, the fact that the magnitudes were bigger leads to many more results. But just first order, to me, this is just what I teach to undergraduates now when I teach them about discounting. It's like people do pay attention. It works. In a setup where they're doing a big decision, for most people, buying a house is a big deal. It's there. It's just not a construct that we use for undergraduates. And that I think to me is first and foremost the takeaway. Now, of course, the paper goes much farther. So let's just figure out what we did. Okay. The first thing is we talked about what are the takeaways. So our interpretation is that this is related to discount. Now, of course, there could be other possible interpretations. So when you write one of these papers, you have to worry about all things that could have gone wrong and could have generated those results and falsified the idea that those results are due to discounting and different maturities. So let's review a few that are possible. Okay, I'm going to go fast because ultimately we're going to say it's not this and it's just not super interesting. But one possibility is maybe there are unobservable property characteristics. Despite the fixed effects, despite the controls, maybe it just so turns out that houses or flats that trade on a lease are much worse than those that trade on a freehold. Now, that one I mentioned, the last data point in the previous graph really helped us because the 700-year leases trade identically to the freehold. So if there was something where all houses on a lease were much worse than the freeholds, they all look, bad, there would be a price difference that would be constant across the maturities. Of course, what that doesn't quite rule out is that there might be price differences coming from unobservables that are correlated with the maturity lease. So for example, when things get on short leases, they get maintained very poorly, and therefore the house deteriorates in quality, but it still has the same square feet, the same bathrooms, the same characteristics, hard characteristics. Now there, we did something that at the time, and I still think it was pretty smart, we managed to get data on rents. So we managed to get data on those properties that are available on the rental market. What do they rent for? And then you can ask the same question. You can say, if rather than looking at prices when they transact, I divide them in buckets and I look at rents, is there a difference? Now that's great. Why? Because if the houses didn't look nice, if there was anything that would affect the price, it should also affect the rents. It should affect how much people are willing to pay to be in the house. And the fact that it didn't provided a pretty strong confirmation across maturities that these unobservables weren't varying, or if they were varying, they weren't price relevant, that were not going into rents. And so this one, I think, for me, was one of the most convincing ways to think about the unobservables. And it's something that Stefano will show you later. We've used also in the context of climate change and disasters. I think this duality between prices and rents can always be quite useful. Now, what are other explanations? One is, let me just shoot them all up. One is, okay, maybe what's going on is that there are contractual restrictions. Maybe the problem is not with the properties, it's with the contracts itself. So anything that says that leaseholders are inferior to owning the freehold and is not related to maturity wouldn't work. Why? Because again, it will show up also for the very long run leaseholds, and instead we find no price difference. So it has to be, the worry has to be more sophisticated. It has to be something that correlates with maturity. Now, could there be more restrictions on shorter leases? And the answer doesn't seem to be yes. And here's another one that we did, which it's using the variation. We control for initial lease length. Why? Because when the leasehold is written the first time, people might put in covenants. And you might think that, for example, shorter leases have harder covenants or more restrictive covenants. But when you're controlling for initial lease length, you're now comparing two contracts that when they trade today, they both have 100 years left. But when they were originally written down with the covenants, one had 300 years and one had 100 years. And so that one is going to allow you to sort of filter this out. What else is going on? Covenants that affect flow utility should also affect rents. So anything that sort of has to do with like renovation costs, investments, anything that people are not undertaking will show up in rents. Anything that has to do with can you do things to the property as it gets shorter and shorter should have very little impact unless it impacts rents, because it's going to be 100 years from now. Okay, that's where we're going. Now, what else could be going on? Maybe it's the buyers that are different. Maybe some people buy long-term, some people buy short-term. They're very different, and there's segmentation. So one of the things that we did is we used the English Survey of Housing to figure out whether people were different among systematic characteristics on whether they bought different maturity leases. And the differences are pretty small. I mean, there are some differences, but they're economically pretty small in magnitude. Could it be liquidity? Could it be financing frictions? For example, it is true that if you have a very, very short term left on the lease, you might not be able to get a mortgage. I mean, after all, nobody's going to give you a 30-year mortgage if you have 5 years left to own the house. But in general, it doesn't matter as you compare, say 200-year leaseholds to 500-year leaseholds, or 100 to 250. Those things are very, very far from coming to be binding. And leases with durations of more than 70 years are treated identically to freeholds when it comes to do a mortgage. Similarly, this is a picture we took in London. I think one of us had gone to take a seminar in London, and we took pictures of a letting agency. You guys probably don't know this, and after COVID, I don't think these things exist anymore. There's like Zillow, but you could see on the window of the agency, we look for one where there's both a freehold and a leasehold apartment. They're sitting next door to each other in the advertisement. They're not being treated differently, where the freeholds are being advertised as prime property, and the leasehold, you have to go in and ask the person, can you take out the book of the bad properties? And that's the only time you figure out that they're available. That's just not the case. Okay, that's the boring stuff. Now let's return to the interesting things. Suppose that this has to do with risk and return and discounting. Then what do we learn about this? And Stefano will tell you a little bit more in the next section, but I'll just sort of lay the groundwork. The first thing we had to look at is the average rate of return over time of housing, which is above 7%. We mentioned before, looking at growth, the growth rate of rents is about 5%. Now, the high returns of rental properties or the high returns of rents are connected with the idea that housing is risky. House prices do tend to go down when you get very big shocks, like consumption disaster, banking crisis, wars. There's both a direct effect in some cases that the housing stock gets destroyed, like during a war, but there's also a price effect, which is even those houses don't get destroyed, go down in value. So that leads to the idea that these are risky cash flows, they're not safe cash flows, and how you want to think about them. So let's fix idea by reminding ourselves that if we use a average high rate of return, so a flat rate across all maturities and high, this will never work. We're going to generate tiny leasehold discounts far into the future. Things should converge to the price of the freehold very, very quickly. So something else has to work. So one thing that you could do is you could say, look, let's use a very low discount rate. Let's lower R to 2.6 and leave G constant. Now you can generate the discount that we're seeing. You can say people will pay 15% less for a 100-year lease compared to a freehold. But the problem is, the catch is, if you have a flat term structure, you will also generate extremely low returns for owning property. You're discounting at 2.6%, the rate of return is going to be thereabout. And that's just inconsistent with the idea that the rate of return of the house is much closer to 6.5. So that one pushed us to then think about models of the term structure that aren't flat, where the discount rate varies through time. And there was an earlier paper actually by Binsberg, Brandt, and Kogin, who had also thought about this in the context of very short-run claims. They were looking at dividend discounts, dividend strips. How much do you pay for the next 3 years of dividends of a firm versus owning the firm forever? That was a brilliant paper that brought in this idea that we hadn't been talking about so much for risky assets. We've been talking about in the literature forever for government bonds, for the term structure. But the fact that there might be a term structure of risk premia wasn't really at the core, and these guys really brought it in, very well. I know I have 3 minutes to conclude, Johannes. I see you looking at me. I will be on time.
You can go a little bit over.
Okay, good. So what we did is that we introduced something very simple. In the next section, Stefano will do a much better job than me about this. But for now, I just want to fix ideas and say, look, one very simple way to get a reduced form discount function and matches the data is to mix two functions. The top one, the numerator here, is what we've been playing around with so far. It's exponential discounting. It's the one that we teach undergraduates. The denominator, the 1 over part, is actually what is called hyperbolic discounting. And if you mix the two, you get a discount function that looks like this. You discount very aggressively short-run payoffs, and then you discount much less long-run payoffs. And the average rate of return is going to be somewhere in the middle. And this creates this very nice shape. Hyperbolic discounting generally has the problem of generating infinite value for things that are too far out. But here you can see what's happening is that the hyperbolic part is dominating the very short run. It's what's making the function collapse. And then the exponential part is what is keeping up the long run. And if you do that, you can match the data quite well. Now, of course, this doesn't say anything at all about where this comes from. In fact, here, we're not talking about risk-free, risk premium, what's moving. This is just simply a math object. It's saying the ultimate discount function that looks like it matches the data. One possibility is that it looks like this. Now, that's where this paper stopped. And our next paper really took that one and said, okay, but where is it coming from? Is it coming from the risk-free rate? Is it coming from risk premium? Is it coming to the exposure to risk? There are many more possibilities. And I think there are many more open questions there. But here, we're just simply saying, look, that would work in reduced form. Why do we care? We care because this is teaching us that things aren't constant across horizons. And so, for example, thinking about discounting the long-run future at the same rate at which we discount things in the short run by looking at asset markets for assets that have 5 years, that might be a very bad idea. Or looking at the government term structure between years 1 and 10, might not be so informative about the term structure 100, 200 years out. There's a lot of shape there that we hadn't quite considered field-wide. And so that's how we got what really the bigger takeaway I think is. Now, of course, as all empirical papers, there's only so much you can say. So there are many things that were left unanswered. One that I want to highlight is how risk changes over time. We really didn't have enough data to figure out how the rents differ in risk in the short run versus the long run. For example, we would love to know whether it's true that after a disaster, rents collapse fast, but then also recover very fast. There's some form of mean reversion. Now that one will generate, as Stefano will highlight, very naturally, a downward slope. And there was an earlier paper by Nakamura, Stenson, Barrow, and Ursua pointing out that if cash flows follow that kind of process, then there is a natural downward slopiness to the discount function. We couldn't really quite pin it down, strictly speaking. So, as usual, at least personally, I love papers that do something simple that teaches us about a first order component of economics, like discounting. Do people discount over long centuries? And then you can go a little bit deeper and say, okay, but how does this jive with our basic models? And then, of course, to make progress beyond that, you need to impose something more than the data. You need to impose more structural assumptions, more of a model to make progress, and the data at some point might not completely pin it down. That doesn't make it useless. It makes it intuitive to learn about the models and make them consistent with what we know about the data, and still think about the bigger picture and other things that we care about. And Stefano will do a little bit of that in the next section. So let me conclude here. I think hopefully this has been a quick introduction, not only to one of our papers, but also to a more general sort of issue of how people discount over centuries. Do we have any direct evidence? The answer is yes. People do think about payouts that far into the future. This is clearly the beginning of the analysis, not the end. There's tons that we didn't do. How that changed over time, how would that change after a disaster? There's lots of interesting things that we haven't touched. But it made some progress on this question. And I think hopefully it also gives you a sense of how we got to work together and how co-authorship started. I mean, this was, when we were on the job market, we're still working together. I look forward to the next paper with these guys. And, I encourage you all as students or as researchers to reach out to people you like and you think are super smart, and just find a fun question to do together. Let me stop here and let Stefano, I think, take over.
Yeah. Thanks, Matteo. Let me just add one more thing, because one of the themes we've talked about a lot in the previous weeks. I think a lot of the students are from all over the world, and one of the questions we get quite often is, well, how do you do data? How do you do work with non-US data, right? Is there any value in it? Is it possible to publish with non-US data, etc.? And I think one of the answers that I've kept giving, and I think this is a great example here, is that actually in many ways, data from other countries can allow you to address questions that you might have no chance of addressing with US data. I mean, in this specific case, that comes because we have this sort of very unique feature of the housing markets in the UK and Singapore that doesn't exist in the US, right? And so you might have worried about, well, is there anything I can learn from these markets that is generalizable to the US? And I think a lot of people have that in their mind, that this is sort of, if you can't, it's very difficult. And I think here, it's an example where you say, no, you can't, but that's actually a strength. And so you try and turn sort of these quirky institutional features that differ a lot around the world. You try and turn that into a strength, and trying to use that to allow you to answer a question that you couldn't otherwise answer with US data. And so I think for in particular for the PhD students based outside the US, I think there is a lot of general focus and maybe a lot of over focus that people have on just working with US data. And I think, when you look at data from other countries, really one major thing to be on the lookout for is these types of things that settings that allow you to address questions that you couldn't do within the US. So I just wanted to add that, as sort of something to focus on